Perfect timing, exactly. And Lucas, our mastermind, is here. He will walk you through the a little bit deepest part of Meta SDK building blocks. So looking forward to hearing from Lucas.
All right. Yeah. How are you, everyone? Nice seeing you, Berhan, Laura. I cannot see the participants here, but we can chat through the messages. I guess you can ask questions. I will be also reading while I'm showing my screen. So I'll share my screen. Um, let's start with that. And with sound. And yes, we're gonna go into a bit more advanced um, series than last session, than Monday. Um, as Laura mentioned, we're gonna look at some of building blocks and some more in like advanced interactions, especially with hand tracking. Um, so my name is Lucas. I'm co-founder from Present Futures. It's a Berlin-based studio. It's our studio. I'm also mentor from for XR Bootcamp. This is a QR code where we can connect on LinkedIn. Um, in my studio,
Lucas, one
yeah.
question. You have again this Zoom on the top and on the right. Maybe if you can,
Oh, yeah, yeah,
yeah,
yeah.
if you
Let
can fix that
me,
again, and if you have share sound, that would be great.
yeah.
I will let you know when it's being.
Um, okay, let me see how can I hide this panel. Is it hidden now?
The one on the top is not.
There we go. That should be good, right?
We have one small rectangle at exactly now. Amazing, perfect.
Okay.
Now we can start from the beginning. So because we will
Yeah.
record this now.
Sorry
Perfect.
about that. All right. So we're gonna do advanced mixed reality development and meta building blocks, as I mentioned. My name is Lucas Martinic. I'm co-founder of Present Futures, a Berlin-based studio. We do experiences in the intersection of art and technology. Um, Things like this that you see here, where we mix technologies like mixed reality with real objects, for example, a slide projector here that we modify at the hardware level to be connected with the headset, right? So basically, you introduce a physical slide and it triggers like the virtual scene here. So yeah, that's the kind of stuff I do day to day. I also develop a series of prototypes that I usually share in social media that maybe some people know. But yeah, let's start with the basic question, right? What is mixed reality, which is what we're going to be talking about today mostly. We have many concepts in XR, right? XR is like the big concept that like encapsulates everything. But we have virtual reality, we have augmented reality, and then we have mixed reality, amongst others. Virtual reality, as you might know, is the one that when you put the headset, then you're totally transported to somewhere else, right? You don't see anything from the real world. Um, Augmented reality, the other hand, is all about still seeing the real world, right? And usually overlaying certain objects. Like the most classic example is Pokemon Go, right? The most popular AR app that, or the first one going like mainstream, right? But then we have like something more like in between, which is mixed reality, where we still also see the real world around us, but we combine it with all the tracking and all the technologies that we have in the other end, like more like in the virtual reality headsets, right? Um, so we can do more immersive um, experiences where we can use depth, we can use occlusion, we can use hand tracking, right? It's like the virtual world and the real world start interacting together. They start communicating between each other. So that's very exciting. That's mixed reality. Um, so let's maybe start differentiating like in images now, right? Like a couple examples. In the left hand, we have, as you might tell, a mixed reality one, right? Uh, where we're interacting with a virtual object, which is a football, like a soccer ball, right? And we are interacting with it with our feet, and it's also bouncing on the real world, right? So it's like this virtual element now is bouncing around our real furniture and walls. And in the right, we have something more traditional where we don't see anything about our real world, right? We have this scene where we control time with this little sand clock hourglass. But yeah, there's nothing real here, right? There's no element from the real world. So we're not interacting with anything. It's just virtual reality, right? Um, Now, let's get a bit more technical. This is another example. And in this example, another mixed reality one, right? Um, so yeah, what technologies are we seeing here? Uh, the, some of the technologies you can tell is hand tracking, right? That's like the most apparent, like most clear one, right? Like you move your fingers and the legs of this puppet moves together. Um, but then also we have some sort of collision happening, right, on the table because this virtual element is colliding with the table. So it's like a scene understanding, right? Um, Now, if I pause the video around here, maybe we can also see that there's occlusion, right? Because my real hand is occluding this virtual object hand, right? So we also have occlusion. Um, and then, yeah, well, mixed reality, right? Mixed reality because we are seeing our environment. So yeah, it's like these four things working together to create like this experience where kind of magical, where like this virtual element interacts with the real world. Um, so how do we develop this mixed reality? As you might guess, Unity and Meta XR SDKs. Um, as you might have learned last session. So with no further ado, let's just jump into Unity because I have something prepared to show. And we are gonna be building this example that I was just sharing. Um, so I'm gonna pull it apart in a way. Let's maybe run it first so you can see how it runs here, and then we start pulling it apart so we can see all the parts that are working together to make this happen. So I'm gonna start my link cable. If you don't know, the link cable is the connection you make with your headset to your laptop, usually your gaming laptop, right? Only Windows works, where you can just run your Unity scene directly, right? So I'm gonna do that. I created the connection now. And now if I I'm gonna cast my scene also, so you can see exactly what I'm seeing. Maybe that's the first step. I usually cast here in what it used to be oculus.com/casting, but now it's horizon.meta.com/casting because it's, in my opinion, more reliable than the Meta developer have. So I usually use here um, the casting. Yeah, works all the time for me. Just a little tip. But yeah, now I'm gonna go back to Unity and I'm gonna run this scene, and you will be able to see here in my casting my pass-through, the office I'm staying right now, right? I'm doing the call from, and you can see probably this puppet there over there, right? So if I move the legs, the fingers, move the legs, can grab it. I can. Oh, I think I don't have the colliders enabled yet. We're gonna look into that later. Can put it there. I can throw it there to the ground. I can make it rotate like that with this gesture and make it run, right? Cool. So that's working. So now let's start understanding how to do this, right? Um, I have a step-by-step that we're gonna follow. The first part is, of course, this doll, right? This rag doll. That's the starting point, and the technique to make this work is something called active ragdoll. So I have a component here that is called active ragdoll. An active ragdoll is a technique that it's better that I show you. It's essentially two skin mesh renderers, two rig models, right? Where the one we're seeing, copies the other, and that works well because we want this ragdoll that we see right on our table to, for example, stay like to stand up all the time, right? To be like trying to maintain that position, right? So what the active ragdoll does is like it usually makes the one we see, the one that's not hidden, to copy the other or try to copy, usually with physics, the other like pose, right? So there's a bunch of games that are like based on these techniques, like Human Fall Flat, for example, or this other party game that was very popular a couple years ago, made in Unity. What was it? Flat Guys, Fall Guys, yeah, Fall Guys, I think. The kind of games which are like very like physics based, right? They usually use the active ragdoll technique. And if I play this now with this second one enabled, right? We can see that this one is kind of copying that one here. This one is not physics based, right? It's just kind of kinematic there. But if I move any part of it, like I move this here, wait, this is the animation roll tool. Let me see. I think it's because I have the headset enabled. Yeah. Let me try again with the hand, shoulder here. Okay. So now if I move if I rotate the shoulder bone, you see that the one here is trying to, it's kind of trying to copy that one, right? But with physics, so it's like bouncy, right? You can see it's a bit bouncy here. So that's like the technique where you want to have like something like more like physics based, like bouncy like that, or that bumps into things, that jumps, that, you know, more reactive. um, yeah, you have this active ragdoll technique. Now my implementation is very simple. I made this is a prototype, right? So I'm gonna show you my active ragdoll implementation, which is here, and it's the simplest thing in the world. I'm not doing any fancy physics calculations. I'm just I just have um, a couple arrays, uh, and then I'm just copying essentially here in a fixed update. I'm just setting the local rotation to copy from one ragdoll to the other. Um, it's, it's just that here in the fixed update. And then I have something I call balancer, which is essentially a point here um, that makes it that just to balance the ragdoll so it doesn't fall, right? We don't want it to fall to the sides. So that part is like kind of fixed. So it's a rigid body. So this ragdoll is kind of joined to that fixed um, balancer. So it's again, it's just like tricks in a way to like achieve this. But yeah, I don't want to go so in depth into this. I just wanted to quickly do an overview because we're more like here for the mixed reality part. But still, um, I think it's still worth like quickly looking into that. So I'm gonna hide again this secondary ragdoll and the here. We're gonna keep the one we see in mixed reality, the animated, the ragdoll one, not the animation one. And then we're gonna go and do the core part, which is basically the legs mapped to my fingers, right? That's kind of like what's the core idea. Trying that in mixed reality. That was the whole point of this prototype. Let's see if it's kind of fun, if it worked at all. So yeah, I just had that idea and I wanted to try, right? And this was the part that took me a bit longer because I didn't well I tried different methods. I tried with maybe the first thing I thought it was like, okay, let's try the meta poses or something like that. Then I did some trials and errors. It was a bit more complicated than I wanted, so I actually ended up again doing a super simple approach. Usually, yeah, you want to find a simpler approach to do your stuff with Meta SDK. I usually try a little bit of their blocks and their sample scenes, but I end up going back to the basics in a way. Um, and what I did is essentially find the bones of my hand um, because those are exposed. Once you add hand tracking into your scene through, it can be like the hand tracking block or the comprehensive rig, like anything that brings you hand tracking to your scene, uh, you will have the bones of your hands in the scene. Um, so that's very some little problem here with my editor. Doesn't matter probably so much. Hmm. But essentially, yeah, I have references to the two bones of my hand. And the bones that matter in this case are basically the base bone of your finger and then the next one, like this one, uh, like um, this joint, and then this joint. You don't need really this for the leg, right? There's no feet, and also it doesn't fall like a feet, this part of the finger, right? So I was just interested in these two bones or joints. So I found those two here in the hierarchy, right? They're called usually something like index one, index two, middle one, middle two, right? Um, and in my script, I referenced those two. Oh, wow. I'm gonna quickly actually just restart my Unity project. It's doing something weird. So let's just quickly do that. So yeah, I found those two bones from my index finger and my middle finger. I referenced those in a couple arrays in this script here, that again is very simple. This is what the script that maps these bones, right, to my legs. And then I have references to the bones for the of the ragdoll, right? So for the leg bone, the main leg bone, um, and then the knee bone, right? So if we see here the script again, oh, still having that issue. Interesting. Um, I have a reference to the left leg bone and the left knee bone of the ragdoll. So this is one again that is disabled, so it's kind of hidden there. Uh, but yeah, it's this here, right? This bone, this bone. And then again, I just said like, okay, let's just say the left bones, the left leg and the left knee should match my the rotation of my finger bone, you know. Let's see what happens. And what happened is this. Oh wow, I need to guess now what's happening here. Um, so what happened is that I got kinda what I wanted, but let's see. So if I run this, and actually I'm gonna run it with this one, enable. All right. So yeah, this is what happened. What happened? So not quite, um, but also not bad, right? Kind of, it's just mapping like my fingers, like I wanted, right? I'm just copying rotations of my fingers directly to the legs of this rig. So when my fingers are like just straight like that, the legs are just kind of um, in the same orientation. But then yeah, it means like the system, like the coordinate system they have, is different, right? Um, because it's not like it doesn't match if I put my hand like that. It's more like it matches when my hand is normal like this. So I just needed to find an offset because this was kind of okay. Um, and then I just experimenting, I found an offset. So I will just um, in code, I will in the rotation, instead of just saying this is equal to that one, I will create a rotation which is only with the rotation the Z axis actually in this case, because I'm only interested in, in moving back and forth the legs, so nothing happens if I separate my fingers like this, right? Not in this case. I was more interested in this movement. Um, I create that rotation, but I also I apply an offset if I have this boolean set to true, right? Um, so if I go to my character and I enable the boolean that now is showing, great. and I apply the offset, boom, I have an offset that now kind of works. And now my fingers kind of work better, right? With the position of and the rotation of this rag doll. Cool. So that was the leg mapping. Very simple at the end of the day, right? Uh, well, once you find our solution. Um, but then again, this is not using any building block, any tool, any specific part of the Meta XR SDK. It's just using their hand tracking, like their raw hand tracking. Um, and I recommend doing that a lot. To be honest, I usually will do that every time I can because it's gonna be simpler than learning sometimes a lot of tools. I mean, Meta has a lot of really useful tools within the interaction SDK and stuff like that. Actually, I'm gonna show you part of the grabbing of interaction SDK. But sometimes you need to just stop and ask yourself, like, what is that I'm trying to achieve, and if there's like a maybe like a just more direct way of doing it before starting to toss building blocks and toss different tools into your scene because you might overcomplicate things. So yeah, next step was making it kind of like collide with my real world, right? And for that, there's MRUK, which is a building block. This is a slightly older version of MetaSDK. So I didn't have it as a building block, but it already existed back then. I think, maybe not. Nowadays, it's a building block. I actually have a different Unity project here. Ah, no, sorry, yeah, it's not a building block per se, but it comes when you add something like effect mesh, right? Which is what I'm using in this case. So effect mesh allows you to access the room data. Now, you know, when you scan your room with the Quest 3, and then you can set up like different furniture and stuff like that. That's something you can access through effect mesh or room mesh. And that usually adds also MRUK component, which is kind of like the brain behind all that, behind a lot of the mixed reality features. So just to get collision, essentially you need the effect mesh that comes with the MRUK. And then here in the effect mesh component, you can filter what you want to show. And then you can set a material that you want the things to show with. You can set colliders, which is what I was looking for, right? So I'm gonna again hide this one, and I'm going to in the MRUK, sorry, in the effect mesh, I'm gonna set a different material so we can have an idea what's happening first. So let's just use something simpler. I don't have anything. I'm just gonna create quickly some material. Just default. I'm gonna assign it here. So now when I play my scene, we'll see that is loading some sort of room, right? This is not the room that I'm in right now because it has a fallback. Like if you're not connected to your headset, you go here to MRUK, and if you expand this here, the data source here is usually set by default to device with prefab fallback. So it will try to get the device. If there's no device, it will do a prefab like this. So this is like just a preset data that you can load to just test things if you're not with your headset. But if I get my headset and I turn it on here and I play, it will load my scene, right? My room, which is just a kind of big room with a table, right? You saw it already. And if I cast here, what? I cast, you can see here, right? I'm seeing my room, but now with this material that I selected, right? So I'm seeing like a virtual version of my room. There's the puppet. But in this case, I didn't want to show anything on top of my real scene, so I just wanted the colliders. So for that, I will just hide the mesh in this case, right? So I want the colliders, I don't want the mesh. And then I'm gonna enable back this offset for the legs that I had disabled earlier to show you. And now I play. That's how my character here is finding collisions, right? Because what is happening here is like I have these cubes, right, that we just saw earlier. Also have my floor with the collider, like the headset. My app is accessing this room data that I showed you just before with this white material, right? But now I hide these visuals, but I keep the colliders. So that's how you can make your mixed reality app to collide with your real world, right? Yeah. So that's collisions. Let's go back to Unity. Maybe I'm gonna quickly check if there's any questions. How can I show the controls now? Or maybe someone can tell me if there's any questions, because I hid the controls so we don't see these squares in the screen. Yeah. So yeah.
You want to go over questions or after the session?
If there's any questions right now, I can quickly go over it. Like, I'm at the half this setup, but yeah, if it's like a question about what I just saw, what I just showed now, maybe it's a good time.
Maybe just one that other can weigh. How big can the room be? Is there a max area?
The max area, that's a good question. Yes, there is max areas. The Quest limits the maximum play space. I think it's 20 by 20 meters. So it's not super big. Yeah, after that you will get start getting warnings about like you getting off limits, stuff like that. But also for creating your room, so for setting a room like this, you might even get a smaller limit. So yeah, that's a good thing to take into consideration. Like if you want to scan like a like a gym, like a big play space, or you might want to go with a different approach instead of using this scene scanning with 3D meshes. You might want to go with more like markers, for example, just to overlay things, or with depth. Yeah, there's definitely a limit. It's not extremely big. It's more like thought about like you in your room, right? It's not thought about like public spaces and stuff like that. So yeah.
And we got two follow-up, if you're
Sorry?
answering them. We got two follow-ups regarding the rooms.
Oh, okay.
How does
Yeah.
it detect a new room? Can it be added dynamically? And whether the room is not stored in Unity, it's saved in the headset.
The room is stored in the headset. You can serialize it to JSON. It's just a bunch of it's just JSON structure that you can actually serialize from the MRUK. So here you can also load a scene from a JSON, but if you go into MRUK class and you just find for JSON, you search for JSON, and there's a couple public methods like say scene to JSON string, load scene from JSON string that you can call like within your app if you want to save certain setup. And then you can even load it here in Unity using this or this method here. So you can scan a real place, save JSON to a file within your headset storage, then you bring it to your computer, and you can load it here if you wanna like work maybe with that reference for your app, right? Like with a real world reference of a room. So yeah, you can do that. What was the other question?
Where is the room stored? Whether it's not in Unity, but it's saved in the headset.
Oh yeah, this room menu thing is here. Like if you go to the main menu, I'm gonna quit the link. Um, you go to settings. You may have a newer UI. I think Meta updated their UI for some people. I still didn't update. I usually don't update right away. But essentially, you go to settings. That didn't change much, I think. And then, where are my settings? Oh, there. Okay, it's a bit slow. You go to settings and then environment setup here. I'm gonna run closer so you can see. And then this space setup that kind of triggers this scanning, right? That you probably have seen. But in this area here, you can scan your room with more detail, and it will like auto generate like these boxes for tables, for example. It will scan windows, doors. Yeah, there's like an array of things, a list of things that it can recognize automatically. But then you can also manually create these bounding boxes that you can later use in your app. That thing you just do it once per room, and then it's just saved in the headset. And that is what you access from the app through this MRUK. So I don't want to update this cam. Yeah. All right, so continuing with our app, mixed reality app. I'm gonna launch my link cable. Taking a long, like running a bit slow my headset. Let's give it a minute. For the grabbing, because you see that I can grab this this puppet, right, with my left hand. I have the option to grab the character. Okay, why is this not launching? Yeah, link cable sometimes a bit finicky. Okay, there we go. Oh yeah, I think it's because I was casting. Sometimes also getting in the way. So now that it's launched, I'm going to cast again. All right. Okay. Yeah. So the grabbing is not so straightforward because, again, this is a physics-based character, right? And but usually grabbing works better with kinematic objects, right? Especially with meta building blocks. They're like more like designed for like more like kinematic things, not so physics based or reactive. So I made like a little workaround where it's like I have this head grab um, object like in the same position as the head, which is actually that's the thing I'm grabbing. I'm not grabbing directly the character. And the character is just it just has a joint, so it's attached to um, this sphere. So if we look at the head of the doll, um, go all the way into the hierarchy of the bones. Um, there's this head base, which is the bone here, which is a physical element, part of the ragdoll, right? What I do is that I procedurally create a joint when I grab. So once I grab this sphere, I have this head grabs component. I just call this reattach joint. We'll just create a joint and attach it. We'll attach the bone of the head to this sphere. And then when I release this sphere, I will destroy the joint. And I will just make the sphere to follow the head, like with code here in the update. Here. So there's no joint. I will just make it match the position. So now I'm gonna leave it enabled so we see what's happening. And what this allows me is that, well, grabbing, right? So you see I'm grabbing the sphere, the gray sphere, and the physical object is attached to the sphere, but through a physical joint, a configurable joint, which is like a Unity component. And this allows me to have like something grabbed that is still interacting with physics, right? Because the joint that is between the sphere and the head still has a physical, is run by the physics engine, essentially. So it's like a workaround where it makes it look like I'm grabbing the head of the doll, but not really. So I can keep um, this physical characteristic, right? So now if I hide the sphere, you don't even tell that that's what's happening, right? It looks like I'm grabbing the head of this doll, and it's very reactive. That allows me to kind of grab it and you know swing it like this, because yeah, it's not that I'm grabbing the head directly. So yeah, that's a workaround that you can use with any interaction where you want to grab something that has some physical elements attached. So what you usually do is, yeah, you have more like grabbing something kinematic, and then the physical element is attached to that kinematic object through a joint, through a physical joint, right? So if we look at the grabbing here, it's just the grabbable. Where is it? Here, grab. Here, it's just a grabbable component from Interaction SDK with a hand grab intractable. That means that that you can do it with hand tracking. And that's it. Just a very like the standard grabbing. What is more special is just like this connection between the two elements, the kinematic part and the physics part. Yeah. So then another thing that I wanted, it was that maybe I can just place this ragdoll, or that I can push it with my hand, right? Since it's physics based. That could be cool, right? So for that, I ended up using this component, which is like an older prefab. It's called OVR Custom Hand Prefab, right? It's still here in the Meta XR Core SDK, but I think they don't use it anymore so much in their comprehensive rig. But I like it because you can just drag and drop it in somewhere. I think it doesn't matter so much, but I just put it here under the right hand anchor. And the thing is that it has these physics capsules that you can just enable here, that automatically will generate capsule colliders for all the bones in your hand. So very easy to just enable this boolean here, and if you play the scene, then it generates all these colliders. So if we look at the hand here, we see colliders here. Let me try. There. So you see, sorry, I'm not showing the right view here. I can push the doll, right? It's a bit hard because also makes it move when I move this hand, but I can also do this, right? So I can stand the doll on my hand, because now my hand has colliders. Oh. But yeah, I can also push it and move it around with the hand. Whoa. The right was a bit unstable with the physics, but does the job. Yeah, so that component, I like it. This there, now we can see the capsule colliders. I don't know why before I couldn't. As you can see here, yeah, you can see these capsule colliders that get generated. They're not updating okay, so I think they don't update like in real time here for some reason in the editor, but you can still see that how it generated capsules for my whole hand, right? That kind of works well. Yeah, so that did it for the collisions, right? When you want your real hands to interact with physical element in mixed reality. And yeah, I mean that was the core. That was the main implementation for this demo. Again, it's kind of simple. Like if you look at from the code side, like the scripts are like this, and this, and maybe this circle detection where I do like this gesture, which is also pretty simple workaround that I made, where I just calculate if there's movement around a point that is following my hand. So it's just these 4 very short scripts. So it's just about like getting your way, knowing your way around a little bit about around the hierarchy. I mean, in understanding like how powerful it is just to know bones like the bone hierarchies for hand tracking, because you can do a lot of things, a lot of cool gestures and interactions just with like calculating distances from bones. You can do gestures with two hands, like if you put two fingers together, you just calculate the distance from this bone to this bone and stuff like that. It's like there's a lot of things to do there, just with this information, this data that you have, of the bone rotations and positions. And I guess I just wanted to show how powerful that is, because that's usually overlooked. But yeah, I also wanted to show, of course, a couple of the building blocks that I like the most. One that I don't have here because it's a slightly older project is depth occlusion. So I have certain occlusion workaround here where the hand has a mesh that can occludes, but it's not proper depth usage. But if you go to a newer, like up-to-date Unity project with Meta XR SDK, the occlusion is as easy to drag the occlusion block. So you just find an occlusion here, drag and drop, adds a couple components there. And then just make sure your material is on the occlusion shader. So you want to find the meta one, that's this one, for example, or just a lead one, occlusion, unlit, occlusion, surface lit, nope, occlusion lit, this one, from the environment depth. So this one, yes, that's the only other requirement. So your object needs to have a material that's with an occlusion shader. There's a few of them, but this is the lead one. And then if I play the scene, you can see that, if I show my right view, okay, that I have this cube here, right? It's kind of behind my laptop. Oops. Oh, I went outside of my playing area. It's behind my laptop, right? And if I go this way, my laptop will like properly occlude it, right? Or with my hand. Well, in this case, I have this virtual hand, but if I didn't, my real hand will also occlude it. I mean, you can still see a little bit, right? So that block, very important, very useful for mixed reality, very easy to configure like that. You can even see here in the Unity editor, like how the occlusion is affecting the rendering here, which is cool. And then the other part that is very interesting that I didn't have time to implement in this old prototype is microgestures, right? Which allow you to do. Okay, I don't have enable here. Let me see. Oh, okay. So it's this component that I have here that allow you to do that, right? So it's very easy to set up, actually. I was pretty surprised how easy to set up, and it's how reactive are the microgestures. So what I did here, I just created this empty game object, and then I added these two components. One is called OBR microgesture event source, which will need a hand reference, so left or right. And then there's this microgesture Unity event wrapper that will just trigger events for every microgesture. So it's very, very straightforward to set up. You just add that, you connect it to the other, and then when I swipe left and when I swipe right, I have this cube, microgestures cube script, very simple thing. that's using DoTween, a very recommended asset, free in the asset store, that allows you to do animations. So you can do you can call methods like do rotate, do scale, do move, and stuff like that, which allow you to animate things with one line of code. So in this case, I'm doing a do rotate 90 degrees in one direction or in the other direction, depending of if I do the micro gesture, the swipe to left or to right. So yeah, I was a pleasant surprise to see how simple and effective the microgestures implementation is, compared to sometimes other meta XR SDKs that are a bit overwhelming. So definitely check that out because very satisfying, also very reactive. Yeah, I think that sums it up for the like more advanced hand interactions and hand gestures, poses, however you want to call it, workshop that I have prepared today. I hope it was useful for any of you. Again, I think hand tracking has like this huge untapped potential, right? And I think Meta is also really looking forward for hand tracking projects in this hackathon. So I will definitely focus on that. If you haven't, decided or started yet, it's really fun, and like a lot of potential there. Yeah, is there any questions maybe? I'm gonna try to find the messages again. There's a command to show them.
We have a few. I can read it
Okay.
up if you want.
Yeah, please, because I cannot see.
Okay. Hello, can you please share the GitHub link of the VS Code snippet of the project demonstration? We should.
I don't have this is not an open source repo. So this is the first time I'm sharing this. But I can share the code here if you want to take a couple of screenshots. I'm not planning to make it open source for now. It's not ready for that, I think. But yeah, happy to just show the snippets of code here again if you need.
Okay. I hope they took screenshots. We have one more question that how to turn JSON into FBX, I think it's asking. Yeah.
JSON into FBX.
Mm-hmm.
So no, I'm not sure. Like you don't need to turn it into an FBX. Well, I guess you could, but you don't really need to because once you have the JSON, it's just as straightforward as pasting it here and saying I want my data source to be from JSON, and then you paste your JSON here that you saved earlier, and that will load the models of your scene. It will create all these procedural meshes with the renderers. So you don't really need to turn it into an FBX. Or maybe what you mean is, yeah, like this question is also being asked a lot. I guess it's like this mesh that you scan, like this low poly like mesh of your room, right? That kind of it's like a more like a one mesh thing. It's called the world mesh, I think, in MRUK naming. The global mesh that I'm not showing here. Yeah, that one, unfortunately, you cannot, as far as I know, you cannot access that from the, you cannot like turn it to an FBX and like download it. But since it's here, like if I disable everything and I just leave the global mesh here, so it's still data that you have in Unity, right? So you could, in theory, let's see, do I have it? No, I need to change the material. So I will just, I need to uncheck the height. So mesh, all runs. No, I'm not getting it for some reason. Because I have this to JSON. Again, I need to change it back to device, the data source. And now, there we go. So yeah, I have this mesh probably you're asking about, right? This mesh, you cannot, they don't have a public method to use it to turn into an FBX, but the data is here, right? It's here in the mesh filter. So you could essentially make a script that copies the data of the mesh filter and saves it into an FBX or something, or serializes it in a certain way, and then you can load. But yeah, there's no, as far as I know, there's no method in MRUK or anywhere to do that directly. So you need to do it manually, kind of. But the data is here, like it is here in the mesh filter, right? There's like an array of positions that define vertices, and also an array of faces, polygons that define normals, and all that. It's all here. It needs to be here, right? It's the only way that this is showing. So you could potentially just create a tool to convert it into an FBX that you can use. That's an interesting little project.
There's a follow-up comment.
Yeah.
Global mesh doesn't save colors and stuff.
No. No, that would be further along the road, and then you need to access the camera, like the PCA, right? And then you want to paint this mesh with what you are seeing. So you want to kind of yeah. What I would do is I will just grab an asset that paints in 3D, and I'll try to make it maybe paint on this mesh, something like that. I think that will be the easiest workaround, but then it changes depending on maybe on the angle, so it's not so it wouldn't be so precise, but yeah, no, it doesn't say color, so you wouldn't need to do that on your own. Yeah, that's more like a longer hackathon project that maybe is suited for a hackathon like this, right? It's interesting. It will be an interesting tool that a lot of people could use.
We have 5 more questions. So, how do you get the file in the headset? Where is it saved? I think it's about saving your room that you were showing.
Well, you can just save in the what is it called? The persistent path, persistent data path. I think it's called something that you can access from Unity classes, which is it's always the same path in Android. So if you connect your headset, the things they always go in the same folder, which is the data folder of your app. So you will just save it to the persistent storage, which is called. Then you connect your headset, and then you will go to your app. So you're going to Android, data, and then you find your app here, whatever it is. And then somewhere here, like in files, you know, or depending on the path, I think you save. I think it might be in files. Yeah, I think it's here in files. That's where everything gets saved if you use that path, which is the standard way. And it's called the persistent data path unity. Oh. So you use this path, application persistent data path. That will automatically like you just save your file there. That will automatically save it in this location in your headset.
I sent the link to the chat, so it's there.
Nice.
Does the depth API work, like, for instance, if the object goes behind the laptop, as I can see the object has occlusion when grabbed by hand?
Sorry, can you repeat that?
Does the depth API work, like, for instance, if the object goes behind the laptop, as I can see object has occlusion when grabbed by hand?
Oh yeah, I mean that's what I was showing here, right? Maybe the question is older. But yeah, in this demo here, no, because this is an older Unity project that I tried to update to the new Meta SDK, but then it was a bit broken, so I decided just to keep it in this version. But then that's why I have this other Unity project with this cube. Not so exciting, but it has the newest packages, right? So in this one, occlusion, yeah, definitely. Let me quickly do this, and I'm gonna make this cube grabbable, like right-clicking on it and going to the interaction SDK, add grab interaction. You just click fix all, create, and that will make the cube grabbable, right? So I'm gonna make it a little smaller so I can show you better. All right, so the cube, I want to disable these hands so we can see my real hands. So I'm just gonna, okay, disable that. And I'm gonna cast again here. All right, so there's a cube. Oh, okay, there we go. Okay, so yeah, my hand is occluding, right? And now, I don't have, oh, I think since I disabled the hand, oh no, I cannot grab it, okay. Well, but yeah, if I do this, you'll see that the laptop is occluding the cube. So occlusion, yeah, it works with anything, right? It's not only with the hands. I can occlude with this. It's just using the depth data of the headset, like this, the sensor, the depth sensor, right? So it's an additional data texture that you have, like a map, the depth map, that just gives you information about like how far elements are in front of me. So here, like the headset knows that my hand is closer to the camera than the virtual object. So it can compare real objects to virtual objects. So, and if my hand is closer to the camera, it should occlude the cube. If the hand is further than the camera, than the cube, it will not occlude it, right? It will like, yeah. So it's just works like that. It's separate from like meshes or scene mesh. This doesn't need the scene scan, for example. This is totally dynamic and just happening in real time, which is cool, right? You don't need to scan anything to have this depth kind of like is working like that, which is why I like it a lot, the depth. Yeah. Is that all the questions?
No. We have also about microgestures. So the microgestures are new to me. Do you know if they work on Quest 2?
That's a good question. Probably yes, because it's just relying on hand tracking, I think. But I haven't tried. You need to try. You just need to enable the. You just need to download the latest Unity Meta SDK. I use the all-in-one, right? So package manager to the Dream project, the all-in-one SDK, 81, the latest one. But or yeah, I mean, couple versions earlier probably fine too. Microgestures were released a couple months ago. But yeah, you just need to use these two components here. And it's easy to just debug if it's working or not. You can just assign something here, whatever, even just a debug log, right? Just writes to the console and tells you, okay, the swipe left gesture was recognized, right, or not. And that will be the only way to know, I guess, if it works for Quest 2. I think it should, just using hand tracking.
Okay. Then we have how would jumping work with hand gesture tool?
Jumping?
Mm-hmm.
You mean like in this case, like in this case of this? Yeah, that could be something you can definitely add, right? With microgestures. I mean, again, I didn't have time to implement the microgestures in this project, but jumping definitely is something easy to implement because you have the swipe up gesture, which is swiping your thumb up like that. And that could be a jump gesture, right? Easy. Very straightforward. Then you just need to add a force to this ragdoll that gives it an impulse up, right? It's a physics object, so you just add an impulse force every time that you do the gesture.
Two more questions, so we are on schedule. What are the basic packages we need to try the microgestures? Is it Meta XR only?
Yes. Microgestures are part of, again, the core SDK, no, the interaction SDK. But I recommend just installing this all-in-one SDK that will come with all these Meta packages, which is better because you'll have everything you need. And it's not really so much more storage that you need to install these packages. So more simple is always to just use this, in my opinion. And that's it. And then you just go to your scene, you add your building blocks, camera rig, pass through the basic stuff, occlusion. And then there's no microgestures block so far as I know, you know. Sorry, microgesture. No, there's no block. You need to implement it manually, but again, it's very simple implementation. You just add these two components, and then you just create certain script that you can call with public methods, right? That you can connect here to the gestures. So you can do it like this, which is simpler, or of course you can also listen to the events directly with code from here. But for prototyping, this is very comfy, convenient.
Okay. We can use, last question, we can use QR to print the cloud data into space without the table, sofas, and stuff. I never understand what to use than people from VR arenas. It's a huge QR code.
Yeah, so yeah, the problem with the scene mesh, like what I was showing here, is that it starts drifting usually over time. So like after a few days, if you're using your app daily, like in an arena, they will do, in a VR arena, it's like a public space where you pay to play, a game with more people, usually multiplayer, co-located game. They don't use this because it drifts over time. It's not so precise. After a few days or so, for some reason, it starts like drifting and being less accurate. So then you need to rescan, reset up, which is a bit annoying. For prototyping like this, works pretty well, but for like a more stable solution, more robust, you use trackers, markers, I mean, usually. So you will have these big markers on the walls, like QR codes or Aruco markers, right? And then you will rely on those because then you can create some certain system that kind of scans your room, but then it anchors the room to the marker's position, right? Um, in the marker position, you don't move it after, right? You have it there. And then every time you start your app will look at the marker and it will position the room properly, related to where this marker is, right? So the marker is more reliable because it's easier for the headset to understand, to position in space, than a room, right? Because the room also changes lighting, you change objects around. There's so many factors that make it not so the most precise thing. But a marker on the wall that doesn't move is very easy for the headset to interpret it, right? So that's why.
Amazing. All questions answered. I think we can move to the AI part.
Super. I will then stop sharing if I can. Can you take cover my sharing while I figure out where my Zoom controls are? There, thank you.
Who's starting, Nigel? Lucas?
I think Nigel is gonna go over a little bit the camera, the PCA stuff,